So, the first chapter that you've read this week was about sampling and sampling theory. And it's important to learn about sampling because in order to maximize on the quality of your results and minimize the cost and effort that you put into a research study, you need to use samples, subsets of the population. So logistically, it's more manageable to use a sample for your study rather than conduct a census examining the whole population. I know you've read this, but I just wanted to go over some of the definitions and how do we differentiate between population, census, and sample and other terms. So a population is a group or class of subjects, variables, concepts, or phenomena. So population could be the citizens of the United States, or it could be the citizens in the state of Michigan. We set the parameters by which we define the population. So a parameter is a characteristic of the population. A census is when we examine every single case in the population. A sample, however, is a subset of the population that is selected through random or not random or non-random sampling techniques. A statistic is a characteristic of the sample. So statistics allow us to estimate the parameters of the population through the analysis of a representative sample. So just to explain what this means, let's say we've set the parameter as the population of the United States. So here's the population of the United States. If we were doing a census, then we would survey or study all of the citizens in the United States. However, a sample is a subset of the population. It is smaller than the population, and we select them based on certain parameters and characteristics. Another important issue with regards to sampling is the error of sampling, of how do we sample. So there are two types of error. There's sampling error and non-sampling error. The sampling error is the amount of error that we can explain from the sampling procedure, something wrong that we have done in terms of sampling. The non-sampling error is error that can be attributed to other factors, such as an error in measurement, whether it's random or systematic. Random errors are unpredictable, where the results are inconsistent from one study to another, whereas the systematic errors are predictable. Every single study produces the same type of error, so it's a systematic error. The results are usually in the same direction. There also can be errors in data analysis. We might run the statistics in the wrong way, or in the study design, how we set up the study. And in addition, there are multiple errors that we don't know of. We try to control everything whenever we set up a study, but there are certain things that we are unaware of that can hinder the results of our study. So the reason why it's important to know about errors is because it tells us about how confident we are in our results, in the sense how confident we are in terms of how does the sample reflect or represent the larger population. And there are different types of samples. There are non-probability samples and probability samples. Non-probability samples are selected without any regard to the laws of mathematical probability, and by contrast, probability samples are selected by following laws of mathematical probability. How do we decide on which type of sample to use? There are different questions that we can ask ourselves. Do I need to generalize the results to the larger population? If this is the case, then I probably should use a probability sample. Do I have the money for a probability sample? If I have the money and the time and the resources to conduct a probability sample study, then it's much better. The other question that is related to that is, will it make any difference? What's the added value of spending so much money on a representative non-probability sample? Um, will I get results that are different from the ones that I would get with a non-probability sample? Also, do I have the time to do it? And the last and most important part is, how much error can I tolerate? Will based on and this is evaluated based on the type of conclusions that we'd like to make out of our study. So if my study does not really require a large external validity, in the sense that the sample that we select has to be representative of the general population, and because we want to generalize to the general population, then I need to worry a lot about the sampling error. If I'm not generalizing to the larger population, such as in experiments, then the amount of sampling error is not meaningful. We cannot, for non-probability samples, it is impossible to calculate sampling error. So let's run through some of the types of non-probability samples and probability samples. We'll start with non-probability samples. There are 4 major types. Available or convenient samples are the samples by which we recruit anyone who wants to be part of the study. Purposive samples, we recruit volunteers that have specific characteristics, qualities, and attributes. For example, if I want to do a study on how women with breast cancer respond to media messages related to breast cancer, then I need to only recruit a specific purposive sample of women who identify as having breast cancer. A quota sample is one where we recruit participants based on a certain set of percentages. We can say that I want to recruit, if I want to compare males and females on a certain variable, then I should recruit 50% males and 50% females. A snowball sampling, it deals with starting with a small group of units and then acquiring information and referrals about other potential participants. So many of you have mentioned this week in your questions that how do we can we sample using Facebook, using our network of friends? First of all, it depends on what you're studying, but there are certain situations where you can put out a link on your Facebook page and tell others to pass it along and put it elsewhere. There are some people who use snowball sampling on platforms, on online platforms, on listserv, even through personal referrals. You call someone and you tell them, can you direct me to people who have these characteristics and who can actually take part in my study? So this is called snowball sampling. On the other hand, probability samples, the ones that are selected based on the laws of mathematical probability, have 5 major types. The first 2 are random samples, meaning that every person has an equal chance of being selected. But we do that in 2 different ways. Simple random samples means that we pick people and everyone has an equal chance to be selected. So a good example of that is drawing names from a hat, random digit dialing, address-based sampling, all of these where we get a list of people and we say, so let's say you got a list of 10,000 people and you wanted to recruit 1,000. So you can put all the name of the people, or all the names of the people, and randomly select 1,000 names from this list of 10,000 names. With simple random sampling, it can be with or without replacement. With replacement, meaning that if you pick a person, you put that person back in the hat or in the sampling framework. Without replacement is you pick the person from the hat and you do not return his or her name to the hat. Another type of random sampling is also um, concerned with giving somewhat equal opportunities for everyone to be in the sample to be selected, but this is based on equal intervals. So we select people based on equal intervals, meaning if we had a population of 10,000 people and we wanted to pick 1,000 respondents, 1,000 participants, then we probably should pick the 10th person. Now, sometimes it's not advisable to always start at number 1. So many people would start probably at they randomly select a number to start from, and then they go down the list and back up to get the 1,000 samples. Stratified samples has two types, either proportionate or cluster. Stratified proportionate samples means getting an adequate representation of the population based on their actual numbers, their actual representation or proportions in the population. So for example, if we want to pick a stratified proportionate sample of the American population, then we look at the census and we see the percentage. Let's say it's going to be based on race. Then we look at the census and we get the percentage of whites in the United States, the percentage of African Americans, of Hispanic Latinos, of Asians, all of the different ethnic categories in the US. And we get their percentages and we make sure to select participants that satisfy the proportion of their true representation in the population. Cluster sampling is similar. However, we base it does not necessarily have to reflect the true proportions of the sample in the population. So we select groups or clusters and we pick participants on that basis. So we could say that I want to collect a sample where I have an equal representation of all the races. So let's say we want to conduct a study with whites, African Americans, Hispanic, Latinos, and Asians, although there are other ethnicities in the United States. But we can say with these four, I want to focus on these four groups, and I want 25% of my sample to be for each of these ethnic groups. So 25% will be white, 25% will be African Americans, 25% will be Asians, 25% will be Hispanic or Latinos. The multi-stage probability sampling deals with conducting random sampling. It could be a combination of all of these, but conducting it on different stages. So we can first start with, let's say we want to pick a sample from a multi-stage sample from the United States. So we have 50 or so states. We want to pick 8 of them. So we randomly select these 8 states. Within the states, we can randomly select certain cities. From these cities, we can randomly select certain neighborhoods. So it goes on. It doesn't have to be 4 stages, or it could be 5 or 6 or 7. So it's basically randomly selecting every level of our selection procedure. So these are examples of probability samples. So the question that the $1 million question is, how do we determine the sample size? Usually the sample size, from my perspective, it has to regard the quality of the sample, whether we are actually selecting a sample that is good enough, of good quality, represents whatever parameters we have put, and also the size of the sample depends on the statistical tests that we are going to use. Certain studies do not need as much participants, whereas For example, if we want to do a survey, then we'd have to go beyond a certain number. So here's a list of the things that we need to consider whenever we decide on an adequate sample size. What's the project that we're doing? What is the method that we'll be using? So for example, for experiments, if it's all within subjects, which we will learn about next week, you can go with 20 to 30 to 40 participants. Whereas if you're doing a survey and you're running advanced statistical procedures, you cannot go below 400. And if you want to do a representative national sample, then probably you cannot go below 1,500 or 2,000 or 3,000. And this brings me to my other point, which is the purpose of the research, whether I want to generalize to the larger population or not. If I want to generalize to the larger population, then I need a bigger sample because I need a smaller sampling error. The complexity of the design, how many cells. So let's say in experiments, again, we'll learn about it next week, we have something called between subjects, which means that people can only see one condition and not the other. So the more cells that we have, the more participants that we need in order to satisfy the power of our results and make sure we have decent effect sizes. Other things include the amount of error that you can tolerate, and we talked a little bit about it earlier. The study design, for example, if you're running a panel study is where you test people at different time intervals. You definitely need to oversample at the first time because people will decide not to participate in the second time. So you need to make sure you have an adequate number of participants to run analyses. Time and money is a big issue. We talked about it earlier, and also past research. It is important to review what others have done and make sure that you are within acceptable ranges close to them. But generally, the larger the sample, the better. However, at a certain point, even if you're recruiting a nationally representative sample, after a certain point, the difference, if you look at the table that you have in the chapter on sampling, after a certain point, the difference in sampling error between 1,000 or 2,000 or 2,000 and 3,000 becomes so marginal so that it doesn't really make a difference to select a larger sample. So select a sample that would get you a satisfactory sampling error and also that doesn't spend money and waste money. And I know that was one of the questions that were asked, and I'll get to it later on. So from selecting the sample size, we move on to what is called the central limit theorem. And the central limit theorem is the sum of a larger number of independent and identically distributed random variables has an approximate normal distribution. So this is the definition that is given by the book. What it really means is that if you have an adequate sample, a large enough sample, and adequate does not necessarily mean large. And adequate means that it really satisfies the power of your analysis, the power of your design. If you have an adequate number, then you will have what is called a normal distribution, or a bell curve, or a Gaussian distribution. And here's the normal distribution. So central limit theorem says that the majority of the responses will gravitate closer to the mean. And what that means, if you can see here, the X and with a line on top of it is the Greek symbol for the mean or the average. And what you can see on the axis here is not the value of the mean, but rather what we call standard deviations. So standard deviations is the distance between a certain value and the mean. So for example, where you see 1 or -1, 1 means that this particular point on the scale means that participants had 1 point more than the mean of the sample. And the same with -1. They were 1 point lower than the sample, 2 points lower. So what it tells us is that the majority of the responses of the respondents will answer in a way that is centered around the mean. And we only have a fewer participants at the tail ends of the normal distribution. So in order to calculate the sampling error, this is the formula that is given. Sampling error of P. P is the percentage that we are recruiting. So let's say, so P is the percentage, N is the overall population, and Z is the Z value, which is the standard deviation by which we decide our confidence intervals. And confidence intervals, so if you notice here, for example, if we want to pick confidence intervals between -2 and +2, then our Z value would be 2. So we're saying this is our sample and we'd like it to be between -2 and +2 standard deviations of the mean. So Z values are predetermined and they correspond to the percentage or the confidence intervals that we select for our study. So let's say that our population has 1,000 people in it, and we've decided to sample 30% of the population. Then using the formula, what is the sampling error at 95% confidence interval? So try to calculate it yourself. You can pause the video and calculate it and check again if you have a similar result. So what we do is we multiply 30 by 100 minus 30 and divide it by 1,000, and it's under the square root, and then we multiply it by 196, and the answer that we get is positive or negative 2.84. So sampling error is always positive and negative because it can be on both sides of the distribution. As you remember, the normal distribution has means that are below, that has values that are below the mean, as evidenced by negative standard deviations from the mean. Also, it has positive standard deviations, values that are above the mean. So what we're doing here is we're saying that whatever results that we'll get from this particular samples could be more or less 2.84 points. And the book gives many examples in terms of elections, and this is especially a big problem when the news media reports results dealing with elections and polling, when they fail to report the margin of error, especially when the results are close. So sometimes when the results are too close and they fail to report the sampling error, the actual results might be different from what they have projected. And we've seen that happen. So if you look at the tables on page 109 and 110, these are important tables. I'm opening my book as well now. So the tables provide sampling error estimates based on dichotomous variables, so that's something that we should know. And let's take an example. So let's say we'd like to recruit a college student sample and compare the use of Facebook between female and male students. Usually college student samples from previous research are around 60% females and 40% males. So before going to the next slide, I want you to open your book and try to locate the answers to the following questions. What is the sample size if we'd like to have a sampling error of no more than 2.8? And what's the margin of error, or the sampling error, if we have a sample of 400 students? So the answer is, in order to get a sample size with a sampling error of no more than 2.8 of 95% confidence intervals, then we need to sample 1,200 people. If we're going to sample 400 students with the same parameters, then the answer, the margin of error or the sampling error, is plus or minus 4.8. So try to locate them on your books, and if you have any problem in doing that, email me and I'll try to explain it further.